We'll proceed in summation to integral calculus. Okay, we are pursuing a very difficult discussion, that is summation to integral calculus. How I can solve my problem, dividing the problem into n number of parts and then solving part by part and then add it, multiply it, whatsoever. The idea is divide the problem in many parts, solve part by part, and then assemble it. Okay, so okay, in that fashion, we can solve our problem. This is what we have been seeing. This is what we are covering as such. Okay, that is called summation, where integral calculus comes into the picture. When we try to assemble all the parts, what we have done, then assembly needs integral calculus. Why it needs integral calculus? That we will see. Okay, I believe many times we have demonstrated this. Why we need integral calculus? We have given very simple example that we have taken is, consider this is a circle and we are trying to find the length of the circumference of the circle. In that fashion, I divide the circumference into n number of parts and calculate the each part length and then add it. Okay, if someone is able to find exact length of one part, then he can add it and he get the full full length. Okay, if someone has technology to calculate the exact length of a curve region, then probably he can guess exact length of the circumference also. But generally, people they do not have that much technology to calculate the circumference of a curve because it is a curve. How you measure the length of a curve? Not possible. What people would do is, if I need to calculate the length of this curve, I would divide it into four parts. This to this one part, this to this another part, this to this another part, and this part. From here to here, this part I'll calculate the length. How I would calculate? This point and this point I'll connect through a straight line, and then I calculate the length, calculate the length, calculate the length, calculate the length, and add it. This is the length of the circumference. Certainly, it is not the accurate one. We are missing the curve part. Okay, I'm sorry. Let's divide into 8 parts. Now divide into 8 parts and then calculate the straight line length. Okay, it is more near to the solution. But this is not the exact solution. Let's divide it into 1000 parts. If you divide into 1000 parts, certainly it will be near to the solution. But it is impossible now to calculate by human, that you take 1000 part and then calculate 1000 part length and then add it. It is not possible by any human being. But still there is error. If n tends to infinity, yeah. If n tends to infinity, then there is a high chance. What high chance? This is exactly at the circumference of the circle. No, no, still there is missing because it's a digital, continuous. There is nothing continuous in the world. There is nothing continuous in the world. If people have doubt upon me, then you can see the sun. Probably in during the sunset or sunrise, it's possible to see the sun. Okay, just watch the sun for 10 minutes. Just keep watching. Since light is very less during the morning time, you can just glare at the sun for 10 minutes. Just see. Okay, sun moves sun moves 180 degree in 12 hours. That is for sure. Sun moves 180 degree in 12 hours. Per hour sun moves how much it is? 3 by 2 degree, 1.5 degree, 1.5 degree sun, 180 degree, I believe 180 degree sun moves in 12 hours. Then it will move 15 degree. 15 degree sun moves in 1 hour. 15 degree is a big measurement. Okay, if I multiply 15 by 6 into 6, it becomes 90 degree. Sun comes to the base level to exactly head only in 6 hours only. Okay, means sun is moving 15 angle per hour. Per hour means 60. Per hour means 60 minutes. 60 minutes per minute sun moves 15 by 60, that is 0.25 degree of angle. In 10 minutes 2.5 degrees sun moves. It is a big thing. If someone is glaring, if someone is glaring at the sun for 10 minutes in the morning, early morning time probably, then he can see 2.5. 10 minutes, 10 minutes is 1/6 of an hour, and 1 hour 15 degree. 2.2.5 degree, I believe. 2.5 degree is a big amount that sun moves. If someone glare 10 minutes toward the someone glare toward the sun for 10 minutes continuous without blinking your eye, try. I mean, I have tried many times, not one time, many times. Okay, just try glaring at the sun for the 10 minutes and see sun moves or not. Sun moves. How I can find that sun moves? Okay, sun would be moving, but how I can say that sun is moving? It's very straightforward to find the sun is moving. Okay, draw a black, take a black wire or something like this. This is black wire. This is black wire. Okay, tie it left to right, black wire. I've seen it. Okay, just tie it left to right. Okay, and then watch the sun. Take the sun. Sun is going up, right? If someone is watching in the morning, then sun would go up. Okay, make sure that sun will be down this line. Sun will be down. The top surface of the sun will exactly touching a little bit down the line, and tie this thread and watch like this. Keep watching, then you will see that sun will cross the top portion of the sun will cross this line. No one would believe this. You will see sun moving. If you can assess without wire also, it is all right. But tie the wire and see the sun. Sun will be below the wire, just below the wire. Keep watching it. 2.5 degree is very big amount, very big amount of the angle. Okay, then sun will cross the line. Means sun is moving. Has anyone see that sun is moving in a continuous manner or discrete manner? Science is science. If you watch anything from your eye, that is completely different. That's why I say feel and do calculus from your own rather than booking reading in the book here and there. It is of no use. Just reading that solar eclipse and lunar eclipse are like that, and this radiation come, right, that radiation come. Then Mars is like this, and then Mercury is like this, and going to planetarium, and then paying money and watching that. Full planetarium is on your head only. Full planetarium is on the head only, and it's free, and it is billions and billions times more enthusiastic and more knowledgeable if you watch from your own eye. Okay, universe is completely different the way we read in the book. The book, whatever the view book gives in the for about the universe, I won't say go and watch the solar eclipse and from your naked eye, that is completely not advisable. But still, there are many other things that people can watch there from the naked eye. Universe is completely different than the way people think. Okay, this is how universe is made. Okay, anyway, so we are talking that how we can calculate. So if n tends to infinity, okay, even though I don't like this concept personally, because it haunts people. That if even though n tends to infinity, then it won't be as smooth. It will be smooth, but still, that is not the best technology. But still, so now if I say what is the length of this, what is the length of this circle, what is length of this parameter of the circle, then divide into n part and calculate the ith part length, that is L, bottom right I, length of the ith part. What is the total length? Summation, sigma sign, summation I equal to 1 to n, I equal to 1 to n. length of ith section. If someone does this, then he gets the net circumference. What is length of the ith section? That is a matter of concern. What is length of the ith section? That is the matter. Someone has to put length of the ith section as a generic formula, and then he can find the summation of n. If n tends to infinity, if n tends to infinity, then it's not possible to calculate the summation. Then it comes as integral calculus. Means if I'm trying to solve a problem through summation, and each part of the summation is approximation. Makes sense? If each part of the summation is approximation, okay, and then then the only way to calculate the exact solution is n tends to infinity. Okay, the way we did calculating the circumference of the circle, if each part length is approximation, if this is the one part connecting this part and this part, it is a straight line. Okay, this is approximation because certainly length is arc length, not the straight line. In that manner, it will not give the exact length, but if n tends to infinity, it's possible. Anyway, okay, rather than going for what is the best mathematics is person should reduce the approximation. We did it. Okay, how to calculate area of a circle? To calculate the area of a circle, there are two ways. Consider there is a Cartesian coordinate system. This is Cartesian coordinate system. Hop, hop, hop. This is Cartesian coordinate system. This is Cartesian coordinate system. This is x-axis, y-axis. Y-axis is dependent upon x-axis, and this is called Cartesian coordinate system. There is another coordinate. Actually, I should have shown as another perpendicular line, but I'm missing the stick. Okay, I should have shown as another perpendicular line. Consider, consider this is polar coordinate system. This is theta and this is r. This is theta and this is r. R is dependent upon theta. In polar coordinate system where they are at 90 degree, any point in polar coordinate system is r comma theta. Okay, now I can change it. This is Cartesian coordinate system. This is polar coordinate system and this is Cartesian coordinate system. This is x and this is y. Y is dependent upon x. Every point in xy plane can be nomenclated as x comma y. Theta and r. Every point here is theta comma r. Now, if I have Cartesian coordinate system in Cartesian coordinate system, then consider that this is polar coordinate system and this is Cartesian coordinate system. In polar coordinate system, consider there is a rectangle. There is a rectangle. If there is a rectangle, means r is not dependent upon theta. In this particular case, if I move on theta, r is constant everywhere. What is mapping of this rectangle into Cartesian coordinate system? If x and y are related to r and theta, the way theta is changing, x and y will change. The way r is changing or whatever it is, x, y will change in that fashion. Okay. Now, this is Cartesian coordinate system and relationship between these two is x equal to r cos theta, y equal to r sin theta. Means relationship is in such a manner that x is function over theta and r, y is function over theta and r. So in xy coordinate system, xy becomes a dependent component and theta and r are independent component. If we take a hybrid model, we try to draw the r theta coordinate system inside the superimposing. This is the best word. If we try to superimpose r theta coordinate system inside xy coordinate system, then certainly they will not map to each other. If this is x-axis, consider this is theta axis, not possible. Because theta and x have certain relationship and x, okay, if this is x, this is theta. If this is y, this is theta. It is possible if x equal to theta and y equal to r. Okay, then this is x, this is theta, this is y, this is r. But that is not the case. X equal to r cos theta, y equal to r sin theta. This gives a hint Okay, I have one more axis and it would look funny. I'm doing some project and there are set of battery that I'm using here. Anyway, so now consider, now it has power because it has many batteries though. Okay, now consider that this is consider what is x now. X is r cos theta. R cos theta means there is a line somewhere connecting the origin, and if I take this is the angle and x is r cos theta, then y is r sin theta. And then if I see the r equal to r square equal to x square plus y square. So exactly it fits in. How to fit polar coordinate system inside the Cartesian coordinate system? Take a line would vary from x-axis going to y-axis, then it will come to here, come back to here. Like a line will rotate like this and it will make an angle theta. Boss, angle theta is a x-axis and r is y-axis in theta r plane. But the way you did, I'm not saying theta is angle. But the way you did, x equal to r cos theta, y equal to r sin theta. If I try to superimpose r theta into xy coordinate system, then it will be r like this and r will go move like this because r square equal to x square plus y square. It is the hypotenuse of x and y. Hypotenuse. X equal to r cos theta, x equal to r looks like this is theta. X equal to r sin theta, this is theta. Y equal to r sin, it exactly fits in. Okay, if I change the angle, r is not changing, but x and y is changing. Makes sense. If r is constant, then x square plus y square root is constant. This forms a circle. This forms a circle. Okay, what is equivalent of x, y in theta r plane? People would ask. If there is a if there is a, if leave the circle concept. If there is this is theta r plane, this is theta and this is r. Okay, in that fashion, what is r and theta? R equal to the way I said in xy plane x equal to r cos theta, y equal to r sin theta. In theta r plane, we have theta equal to tan inverse y by x. Forget it, xy plane. Just think that there is a primary theta r plane and theta equal to tan inverse y by x and r equal to x square root of x square plus y square. Not draw it. I know drawing or draw the x and y the way I drew the kind of here the way I drew the r theta in xy plane. If that is the x equal to r cos theta. If I consider r as constant, if consider r as constant, then x will be r cos theta. Means x will at the beginning x will be at r height and cos theta. Theta is 0 here. This is theta axis. This is r axis. What is x axis and y axis? We don't know. X at angle theta 0 and r cos theta means x is r at angle 0. X is here. At angle pi by 2, angle is going in radian. At angle pi by 2, x is 0. Then x will go as a cosine wave. X is like this. Y equal to r sin theta, y will start from 0 and pi by 2 it will reach maximum and then at pi it will reach minimum and it will go like this. So there are two waves, they are going like this. One wave is x wave r cos theta and one other is y wave that is r sin theta. What about r is function over theta? That is also possible. That r is function over theta. The way if I say I have a circle in xy plane, then y is function over x. Y and x are not independent. When y and x will be independent? Y and x will be independent only when y is constant. That will form a rectangle. Consider r is function over theta. R equal to cos theta. If that is the case, then x equal to cos square theta, y equal to sine, y equal to cos theta sine theta. Then we have to draw graph in theta r plane like this. X equal to cos square theta. If this is theta, then x equal to 1. Okay, if it is pi by 2, then x equal to 0. but it may not go like a cosine because it is cos square theta. Everywhere I have to do a square. At theta equal to pi by 4, 45 degree, cos theta is 1 by square root of 2. But whereas cos square theta will be 1 by 2. It may not be exact circle, but the way it is how it is. Y equal to cos theta sine theta. Then if theta is 0, it will be 0. When it is theta is pi by 2, it will be 1 by 2 again. When theta is pi by 4, pi by 2, then cos is 0. So 1, I'm sorry. Hope, it is very different. Okay, y equal to r sine theta, r equal to cos theta, y equal to cos theta sine theta. If theta equal to pi by 2, then cos pi by 2 is 0, whereas sine pi by 2 is 1. Means it will start from 0. It will go maximum, I believe, at angle 45 degree, that is 1 by 2. It will go like this and come back. Makes sense? If I grow beyond 90 degree, then cos theta will be negative, whereas sine theta still it will be positive because perpendicular by hypotenuse it will be positive. More or less multiplication will be negative 1. Means it will go like this. I'm sorry. The y will go like this, up and down, up till 90 degree. Then it will go in negative direction maximum and it will come like this. Okay, that is at pi by 2. 0, 0, pi by 4 it will be maximum, it will come to pi by 2 as 0. Then at 135 degree it will maximum in negative and it will come to 0. Like this it will keep doing. Okay, at frequency, means it will get repeated at every 45 degree, every 90 degree. Otherwise, if I take cosine wave, it will get repeated in a way at 180 degree. It will go down. Means it will touch horizontal axis at every pi, whereas cos theta sine theta will touch horizontal axis at every pi by 2, whatever it is. Okay, this is how it is. This is how the diagram of x and y in the r theta plane driven by r equal to square root of x square plus y square and theta equal to tan inverse y by x. Anyway, what is the problem that we are actually trying to address? This is also called Jacobian. What we did, if we remember from the past discussion, we are trying to calculate the area of a circle by dividing the circle into n different parts. This is what we are trying. By dividing the circle into n different parts, we are trying to calculate the area of the circle. Okay, now to do that, we this is xy plane. If this is xy plane, if this is xy plane, if this is xy plane, then this is radius, and radius is moving like this. Radius is moving like this. Okay, this is making the first section, this is making second section, this is making third section of the area, this is making ith section of the area. Okay, then like that, then it is making nth section of the area, last section of the area. How to find any ith section? To get the ith section area, we take a concept of cross product of two vector leads to the area. If I calculate cross product of any two vector, it leads to an area. If this is a vector, that is radius, and this is the arc vector, then cross product of arc vector and radius vector will lead to an area that will be between these two vectors. If this is a vector and this is a vector, then cross product of two vector will give the area in between. Okay, in that fashion, if I take cross product of this vector and a arc vector, a curve vector, curve vector if I represent through a vector, curve vector cross product with this vector will give the area underneath it, in between. So that concept we will use to calculate the area. What is the area of a circle? Summation I equal to 1 to n, area of the ith section. Area of the ith section is this. This is the area of the, this is the area. This is the area of the ith section. Area of the ith section. This is the curve. If I take out, this is area of the ith section. This is the curve. If I do cross product of this, this one, this one, and this one, then I get the concept of area between this line and this line. I'm discarding this line right now. Okay. What is the this vector and this vector? First of all, we have seen that there is something called length vector, a vector that represents us a line, a curve. Curve can be a straight line, curve can be curved line. Okay, if I take into polar coordinate system that is inside the Cartesian coordinate system. If this is a Cartesian coordinate system, then there is a polar coordinate system hidden here. That is, this is radius and it is moving like this. If there is a point here, so if I'm taking the ith section, if I'm taking the ith section, then this point can be demonstrated as from origin it is radius r, and from origin this is the angle called theta. I can say this is r comma theta, but this is not r comma theta in polar coordinate when it is superimposed on xy plane. In that fashion, it has to be in length manner only. If this is the length, then another point that is theta, it should be in length only. So theta, if I represent in length, then this will be this arc. When this point is this distance from origin and this distance for the theta. This point is r comma r theta, where theta is angle here. Makes sense? With the x-axis, it makes angle theta. This point is r comma r theta. This vector position vector is r unit vector plus r theta unit vector. So this is the representation. If I want to represent any position vector, how I represent a line, how I represent a curve line, how I represent a curve line through a vector. We have talked it, I believe, millions of times. Means if I want to represent a line through a vector, then if this is x-axis and this is the line, okay, then if I want to represent this straight line as a vector, consider this point is x comma y. This point is origin. Then there, if I draw a vector, vector will be along the line. That is the vector representation of the line. That is xi plus yj, where y is dependent upon x. Like consider this line equation is y equal to 2x. Then the vector will be xi plus 2xj, whatever it is. This is the vector representation of a straight line, xi plus yj. You can replace y with the x. But if I want vector representation of a curved line, then that will not work, because if I take how I represent a vector equation of a curved line from origin to point x comma y, then if I take vector representation, then I will take a straight line only. I want curved line. A vector will go along the line. In that fashion, we see that for a curved line, everywhere y by x, y by x, y by x is variable. To represent anything, we try to find a variable component in that thing, and then we have to represent that algebraic equation through variable component. Then we represent the curve. So y by x is variable in case of a curve. Now I will make y by x. So vector representation of a straight line is xi plus yj. Take out x. It becomes I plus y by xj bracket goes into x. If I if I put it into calculus, where division will become differentiation and multiplication will become integration, it will become I plus dy by dx j bracket closed into dx. This is the representation of a length vector, a vector that represents a curved line. Similar manner, if I am trying to calculate uh, cross product of a length vector, that is radius vector and arc vector. Okay, vector in polar coordinate is r comma r theta, r unit vector plus r theta unit vector. Okay, what is the area concept if I do the cross product of these two? What is the radius vector? If I want radius vector, then r is variable component here, because r is varying. If I take ith section, this is ith section we are talking, that I have to calculate the area, because net area is summation I equal to 1 to n area of the ith section. Okay, area of the ith section if I want, then I am trying to calculate it through calculating the cross product of radius vector and arc vector. Okay, radius vector and arc vector are same. Only difference in radius vector, radius is variable. In arc vector, theta is variable. Now I have two vector cross product. One vector is r plus r theta, r unit vector plus r theta unit vector. Another is same thing. r unit vector plus r theta unit vector. If I do cross product, I'll get a kind of area between this arc and this. So first one I have to take out r independent component. Second one I have to take out theta. Now first representation will become dr by dr. First I take out r, it becomes r by r unit vector plus r theta by theta unit vector into r. Another will become r by theta, r unit vector plus r theta by theta unit vector, bracket close into theta. If I place into calculus, it will become dr by dr, r unit vector plus r d theta by dr, theta unit vector. Cross product dr by d theta r unit vector plus r d theta by d theta, theta unit vector, bracket close. From this side dr, from that side d theta will go outside, dr d theta. Okay, first one become exactly like dp by dr, where p position vector is r unit vector plus r theta unit vector. dp by dr cross dp by d theta, bracket dr d theta. This is the area between arc and this. If I analyze this, then it becomes dp by d theta cross dp by dr, dp by d theta cross dp by dr, or more or less I can say dp by d theta r. If there is a 1 unit of area change, if there is 1 unit of area change in theta r, dp, where position vector is in xy plane, minded. P, what we are talking, it is in xy plane or Cartesian coordinate system. D of P by D of theta r into d theta dr. Leave that part. This part, many times we have demonstrated this. dp by d theta r. If there is dp by d theta r will talk in a way that if there is 1 unit of area change in theta r plane, brings how many of unit area change in xy plane, dp by d theta r. If I know this rate of change and then if I multiply with the dr d theta, or 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 if I take ith section, then delta theta, this is delta theta I, and consider this radius is changing. Radius is a function of theta, then the here radius will be different, here radius will be different. Then it becomes delta theta I into delta ri of the ith section. More or less the area of the ith section becomes dp by d theta. Change in if this is point P, then change in position vector in an area concept per unit change in theta r into how much is the theta r. This is delta theta I and this is delta ri, r1 minus r2 delta ri. Okay, this is the area of the ith section. Summation I equal to 1 to n. Where n tends to infinity, then this will come into integral calculus. Please watch our previous video, how to convert indefinite summation into integral calculus. Then it will become theta r begin to end dp by d theta r into d theta dr. Okay, there we tried same fashion for the Cartesian coordinate system. If dp by d theta, dp by dr cross dp by d theta dr, it gives the area in polar coordinate system that is drawn inside the Cartesian coordinate system. Can I try with dp by dx cross dp by dy and then dx dy? Means I'll take length vector at xi plus yj, xi plus yj cross xi plus yj. First I'll take out x and another side I'll take out y as independent component. Here is the problem. If I am talking in Cartesian coordinate system and if I taking cross product of two vectors, if I watch the ith section, then there are four things. One is change in the radius, that is delta ri I am saying. Change in the angle, this is delta theta I am saying. There is change in x also. If this is making here on x-axis, this is making here on x-axis. This difference is called delta xi of the ith section. This is delta yi. That is also there. In that fashion, can I represent this as a length vector in xy coordinate system, x, y as variable, and this is at x as variable? Then I can say the cross product of this and this is xi plus yj cross xi plus yj. From one side, I'll take out x, considering x as independent component. It will become I plus dy by dxj, bracket close into dx. Cross product, another side, I'll take out y considering y is independent component. That is not true. In xy plane, y is dependent upon x. That's why it is a circle and equation is y equal to square root of a square minus x square. Y is dependent upon x. It is not a rectangle, it is a circle. In that fashion, I cannot take cross product of two length vector where one is x is independent and another y is independent. At the beginning only it would fail. Whereas we took theta and r as independent component because theta and r are inside Cartesian coordinate system. They are not theta. We are not doing the stuff in theta r plane. We are doing stuff in xy plane, and theta r plane is forcibly imposed here. There is no theta and r axis. This is x axis, this is y axis. R is going like this, radial, and theta is going like this. They are not like, if I take theta r plane, then this is theta and this is r. Here, if I draw x and y, then x will go like a cosine wave. There is no x axis. X is moving like this. Y is moving like a sinusoidal, like this. There is no x and y. Similarly, if I take theta and r in xy plane, then r is going like this, and theta is going like this. They are not in their coordinate system. They may not get x axis, y axis. Similarly, if I talk about theta r plane, then this is theta and this is r. If I draw x and y here, x and y may not get, this is x and this is y. X will be in subcurve fashion. This is what we drew. Anyway, how to do computation in xy, that is comes in the question. Or I am forced to do calculate the ith section area in r and theta only. One clue people would suggest that go to theta r plane. If you do r and theta as an independent component in xy plane, go to theta r plane, and there xy is independent and theta r is dependent, where r equal to square root of x square plus y square and theta equal to tan inverse y by x. Actually, if you go there, then the area of the ith section, what we are talking, any ith section, there if I cut down the x, y or whatever it is, area of the ith section will come at dp by dx cross dp by dy dx dy, but this is possible only in theta r plane, not in xy plane. Here dx and dy are independent to each other. They are variable and they are independent to each other. Dependent is r and theta. Now what is p here? Position vector. P is r unit vector plus theta unit vector, not r theta unit vector. Theta unit vector. In theta r plane, every point is r comma theta. But in xy plane, if I talk in every point is x comma y, or every point is r cos theta comma r sin theta, or every point is r comma r theta. Makes sense? Similarly, if I go here, then every point is r comma theta, not r comma theta, r comma theta, or every point is the square root of x square plus y square comma tan inverse y by x. Make sense? Okay, people can think more than this also. Now here if I do dp by dx, the way here I did dp by dr cross dp by d theta, d theta dr, here I can do dp by, this is theta r plane, dp by dx cross dp by dy magnitude dx dy. It will give the area of the circle that is in sinusoidal form here. That is circle here and here in sinusoidal form. Okay, x is minus r to r and y is minus r to r. I tried solving it and it comes the r comma position p is r unit vector comma theta unit vector by dx cross d of r unit vector plus theta unit vector by dy cross and then dx dy. R unit vector will become a square root of x square plus y square r unit vector plus theta unit vector will become tan inverse y by x theta unit vector by dx cross same thing by dy. I did cross product. Okay, first I did the differentiation and it came in r unit vector and theta unit vector. Here also r unit vector and theta unit vector. Then after doing the differentiation of square root of x square plus y square will come as minus x by square root of x square plus y square with dx. With dy it will come as minus y by square root of x square plus y square. Tan inverse y by x. Tan inverse x differentiation is 1 by 1 plus x square. Someone can find out. It's very easy. So 1 by 1 plus x square. So tan inverse y by x differentiation with x, it would give 1 by 1 plus y square by x square into y into 1 y into minus 1 by x square. Tan inverse y by x differentiation with y will give 1 by 1 plus y square by x square into 1 by x. If someone does the cross product and settle it down, I got 1 by the square root of x square plus y square. Amazingly. Now, here I stop because beyond that it is very difficult. So, integration sign, x and y, x is going minus r to r and y is going minus r to r. 1 by the square root of x square plus y square dx dy will give the area of circle when we try to compute x and y as independent component in theta or plane. Okay, now people would say, can you do it in XY coordinate system only? But in XY coordinate system, I can do only for the R and theta, not an X and Y. Try it. Okay, I tried it. R and theta, if I do, then integration sign dp by dr cross dp by d theta. It comes as r d theta dr. Can you convert dr d theta into dx dy? Then it should be possible. We'll try. What is r? R is 1 by a square root of x square minus, I'm sorry, r is the square root of x square plus y square. That we know. Dr d theta. I can convert r into x and y. Okay, in xy coordinate system, the area of the ith section of the circle is is r into dri d theta I, summation I equal to 1 to n. If I make it as integral calculus, it become a limit sign r dr d theta. If I want to do convert into Cartesian coordinate system, then r would become, first I have to settle down the limit that we will do. R would become a square root of x square plus y square. Dr d theta is not possible because dr d theta can be combined as d of r theta. D of r theta, how we can do? Not possible in x and y. We will try. Okay, how we achieve this is called Jacobian, reverse Jacobian. Dr d theta, how I can write in x and y. R I can write in x and y, that is square root of x square plus y square. Make sense? How we can write in Jacobian or something like that. Okay, I'll start for the concept of Jacobian. Now there are two axes now. This is called x-axis, this is y-axis, xy plane. And this is r theta plane. Okay, now they are mapped. If there is a rectangle in r theta plane, then in xy plane there is a circle with a relationship x equal to r cos theta, y equal to r sin theta. Okay, now consider here in the rectangle there is a point called r comma theta. If I move along theta delta theta and in r I move delta r, it forms a rectangle whose width is delta theta and width height is delta r at point theta comma r. Corner point will be r plus theta plus delta theta comma r plus delta r. This area is delta theta delta r. Makes sense? There is a point in theta r plane called theta comma r. I move delta theta and I move delta r. Then I reach a point called theta plus delta theta comma r plus delta r. This is a rectangle that is delta theta delta r constructed between 2 points. One is theta comma r and one is theta plus delta theta comma r plus delta r. Okay, accordingly, if I take a point here for theta comma r, I have x comma y. Consider for theta plus delta theta comma r plus delta r, I have then accordingly I have another point called x plus delta x comma y plus delta y. Make sense? What is delta x into delta y? This is what we are trying to say. What is delta x comma delta y? This is what we are trying to find out. What is the area? Makes sense? What is the area here? What is the area here? This is delta theta delta r. What is the area here? Delta x into delta y, but they are related. How to find delta x into delta y? Here Jacobian comes into the picture. So what it says is that for r comma theta, take a point here at x comma y. What is x comma y? Function over r theta and function over r theta again. Consider that point x comma y is x equal to r cos theta and y equal to r sin theta. That is the point in xy coordinate system. That will come at, say x equal to r cos theta, x equal to g of r theta, function over r theta, y equal to h of r theta. If there is r comma theta point is here, then here point is g x comma g r comma theta h r comma theta. If there is a movement in delta theta, then there is another point. Consider that point is P1. If this point x comma y is P, another point is P1. P1 is g of theta plus delta theta comma r comma h theta plus delta theta comma r. From theta comma r, I move up. Now this point is theta comma r plus delta r. Accordingly, I move up. There is a point called P2, and that is g comma g function, that is x, g theta plus theta comma r plus delta r comma h theta comma r plus delta r. This can be P and P1 can be represented as a vector, and this can be represented as vector because it may not be a rectangle. Here it is rectangle. What is the area of this shape? P1P cross P2P. If I do cross product, it gives the area. How much is the area? What is P1P? What is P1P? P1P is G theta plus delta theta comma R comma H. H function is for Y and G function is for X. G bracket theta plus delta theta comma R bracket close comma H theta plus delta theta comma R. I'm sorry, the P1P vector what we are talking is G theta plus delta theta comma R G minus G theta comma R comma H theta plus delta theta comma R minus H theta comma R. If I talk in vector form, it will come as G theta plus delta theta comma R minus G theta comma R I vector plus H theta plus delta theta comma r minus h theta comma r j vector. This is P1P. P2P will be in similar fashion. G theta comma r plus delta r minus g theta comma r I vector plus h theta comma r plus delta r minus h theta comma r j vector. If I do cross product of these two, then I get area in xy plane that is formed because of delta theta delta r change at point theta comma r. Okay, if I do cross product of these two, okay, if I do the cross product of these two, then how it will come? It will come as g theta plus delta theta comma r I I plus g theta h theta plus delta theta comma r minus s theta comma r j. Okay, cross product with g theta comma r plus delta r minus g theta comma r plus theta comma r I vector plus h theta comma r plus delta r minus h theta comma r j vector. These two cross product will give this area. Whatever the area is, I can divide it by delta theta delta r and multiply it with delta theta delta. I can do. In mathematics, I can divide by an amount. I can multiply by the amount. If I divide by delta theta delta r, it becomes like this. G, now I keep delta theta on left side, delta r on right side, or I can keep, this is what I'll do now. If I divide whatever we have, P1P vector, P2P vector, P1P vector, P1P vector, cross product P2P vector, divide by delta theta delta r into delta theta delta r. If I settle it down, I can rewrite as P1P vector by delta theta cross P2P vector by delta r. I took two sides and cross product. First one will become G theta plus delta theta comma r minus g theta comma r I vector plus h theta plus delta theta comma r minus h theta comma r j vector by delta theta. This is exact form of first equation in derivation. The first equation, first derivative, first principal equation in differentiation is like this. If I say I have a function called dgh by d theta, d of g comma h, d is a function, h is a function, that is x and y. D of g comma h by d theta, how you represent? It will come as g theta plus delta theta comma r minus g theta comma r comma h theta plus delta theta comma r h theta plus delta theta comma r by delta theta. This is dgh by d theta. This is dp by d theta. because G and H is x comma y or xi plus yj, that is position vector in Cartesian coordinate system. This becomes dp by d theta. Another becomes dp by dr. dp by d theta cross dp by dr bracket close into d theta dr is the area in xy plane that correspond to area here, that is delta theta delta r. Makes sense? Delta theta delta r brings this much area in xy plane, but area in xy plane is actually delta x delta y in abstract form. We said that if because of delta theta x also changes, I say delta x, delta r change, I say y is changing, I say delta y. Area here is delta x delta y in abstract form, means delta x delta y equal to dp by d theta cross dp by dr d theta dr. dp by d theta cross dp by dr would become r. Someone can calculate. This is called Jacobian, means dx dy in Cartesian coordinate system becomes r d theta dr. In similar fashion, I have to calculate anti-Jacobian. What is dr d theta? How it will become dx dy? We know dx and dy become r d theta dr. Take reverse fashion now. This is xy coordinate system. This is theta r coordinate system. In xy coordinate system, take any point x comma y. Here that point will come as function over x and function over y. That is r comma theta. Reverse fashion. Now here make delta x change. Here make delta y change. In similar fashion, here it will become delta r and delta theta and delta r in abstract term. Actually, it will become, if this point is p, p is mapped from x. Reverse we are doing now. If there in Cartesian coordinate system there is point x comma y, accordingly there is a point here called function over x and function over y. That we are saying that point is f x and y, sorry, g x and y, h x and y. If I move delta x there, then there is another point. Here, for delta x movement, I moved here again. That point is P1. P is gxy, hxy. This is P1. G of x plus delta x comma y, h of x plus delta x comma y. There is another point called P2. G of x comma y plus delta y, h of x comma y plus delta y. If I do cross product of P1P and P2P, I get area here. That area in abstract term we can say delta theta delta r, but actual area is delta x delta y. According to delta x delta y, we have area here as p1 cross p1p vector cross p2p vector. Okay, it will come in equation like dp by dx cross dp by dy. Same in reverse fashion. dp by dx cross dp by dy, dx dy. Makes sense? This is what we want. dp by dx cross dp by dy, dx dy anyway. Now we are talking about the area that is formed in the theta r plane, that is delta theta delta r, means d theta dr equal to dp by dx cross dp by dy, dx dy. Now I go to the original problem where in Cartesian coordinate system we try to find out the integration area through the ith component and summing it. It becomes integration r dr d theta. Dr d theta can be rewritten as dp by dx in polar coordinate system. dp by dx cross dp by dy, dx dy. R can be written as the square root of x square plus y square. Net area calculation in Cartesian coordinate system is theta r begin to end, that will be mapped as x y begin to end, and then r dr, r become a square root of x square plus y square. Dr d theta would become dp by dx cross dp by dy, dx dy, where p is in r theta plane, where p is r unit vector plus theta unit vector, or p is p p r is the square root of x square plus y square, theta is the square root tan inverse y by x, dp by dx cross dp. That I have said it, I have calculated it. This will become 1 by a square root of x square plus y square. So net it will become a square root of x square plus y square into 1 by a square root of x square plus y square dx dy. It will cut down and it will become dx dy, an integration of x to y, where this is a circle in xy plane. So x will go from here to here and y will go from here to here. Y is a function over x. X will go minus a to a and y minus a to a, and y would go minus a square root of a square minus x square to square root of a square minus x square dx dy. Okay, in that fashion, if I compute y first, then it will become y. 2 into a square root of a square minus x square. 2 I can keep outside. A square root of a square minus x square dx. X equal to, take any arbitrary x equal to a cos theta. Then a square root of a square minus x square would become a sine theta. Dx would become a minus sine theta d theta. A square I can keep outside. 2a square is waiting outside. If 2a square is waiting outside, it becomes minus sine square theta d theta. Theta by 2 minus sine 2 theta by 4. Theta is begin to end. How much is the theta? If I say minus a to a, then theta will go pi degree 1. Minus a to a, theta will move pi degree 1. In that fashion, it will become 0 to pi. This is not the actual explanation that x is going minus a to. We can try x equal to a cos theta we have taken. Theta equal to cos inverse x by a. Okay, if x is 1, if x is 1, x is a, then it becomes cos inverse 1, cos inverse minus 1. Cos inverse 1 is 0. Cos inverse minus 1 is pi. Actually, limit will go 0. Limit would go pi to 0. Okay, pi to 0. A negative is outside. Theta by 2 minus sine 2 theta by 4. It will become pi by 2. Minus minus cut down pi by 2. Outside 2a square is waiting. Pi a square is the area. Okay, so we can compute the area through the repeated summation and through reverse Jacobian with the xy in the xy coordinate system only. No need to go for the volume concept that we took in 2 videos prior. That we cannot compute the repeated summation in xy coordinate system making x-axis variable and y-axis variable, because both are not possible in xy coordinate system because y is dependent upon x. I have to go to 3D model where z is dependent upon xy plane, where x and y are independent. We need x and y independent. Okay, in that fashion, first we tried r theta, then we tried 3D model. Now, if I want not 3D model, then I have to go to reverse Jacobian, where we do computation in xy independent component in r theta plane and r theta independent component in xy plane, either of which we can solve. We took this way because we are familiar to this. But whatever we had proceeded here as x and y coordinate system, that I used as a reverse Jacobian, and we can solve it. Someone can try more on it. This is certainly way, way, way away that it would be mentioned in any of the book. Not possible. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.